In the early 1800s, fishermen in the Bay of Fundy, a Canadian inlet famous for having the highest tides on Earth, would tie their boats to the docks in the morning and return in the afternoon to find them dangling several meters above the water like fish on a line. No storm, no earthquake, just the daily rhythm of the sea doing something truly strange. This daily rise and fall of water, sometimes gentle, sometimes dramatic, is called a tide. But what exactly causes the ocean to go back and forth with such regularity? Why do beaches appear and disappear like magic? And what does the moon have to do with it? First, imagine the Earth as a giant water balloon. Now picture the moon as a gravitational puppeteer gently tugging at that balloon from 384,000 kilometers away. It's not pulling just on the surface. It's pulling on the whole thing, land, sea, even the atmosphere. But because water moves more easily than solid ground, the ocean responds more noticeably. This tug is caused by gravity, the invisible force that pulls objects toward each other. The moon's gravity pulls on the Earth, and that includes its oceans. The ocean closest to the moon gets pulled toward it, creating a bulge, or a high tide. So why is there a second high tide on the opposite side of the Earth? It turns out the Earth itself gets pulled ever so slightly toward the moon as well, but the ocean on the far side lags behind due to inertia. So as the Earth is tugged toward the moon, the water on the far side effectively bulges away from it. The result: two high tides and two low tides every day, like the Earth is breathing in and out, but with water. Because the Earth is spinning on its axis once every 24 hours, different parts of the world rotate through these bulges of ocean water. That's why most coastal areas experience two high tides and two low tides every day, each roughly 6 hours apart. But tides aren't like clockwork, because the moon is also orbiting the Earth, and its position isn't fixed. Add in the elliptical shape of both the Earth and moon's orbits, the tilt of the Earth, the depth of the ocean, and the shape of coastlines. The moon may be the main conductor, but the sun doesn't sit quietly in the audience. It, too, applies a gravitational pull on Earth, and it's much more massive than the moon. But since it's also much farther away, its influence on tides is only about half as strong. When the sun, moon, and Earth are all in a straight line, during new moons and full moons, their gravitational pulls combine to create spring tides. These tides have higher highs and lower lows. But despite the name, spring tides have nothing to do with the season. The term comes from the Old English word springen, meaning to rise. When the moon and sun form a right angle with the Earth, during the first and third quarters of the moon, their gravitational pulls partially cancel each other out, creating neap tides, which are more mellow, with less difference between high and low tide. Let's go back to the Bay of Fundy. There, the tide can rise and fall by over 15 meters, taller than a 4-story building. Meanwhile, in parts of the Mediterranean, the tidal difference might be just a few centimeters. Why? It all comes down to geography. The shape of a coastline, the depth of the water, and even the width of a bay can amplify or dampen tidal effects. In the Bay of Fundy, the natural funnel shape of the bay concentrates tidal energy. If the timing is just right, each incoming tide reinforces the last one, creating a resonating effect called a tidal resonance. In other words, some places are perfectly designed to catch and magnify the moon's pull, Long before we had clocks or calendars, ancient people watched the tides. Coastal cultures learned to read them like nature's timepiece. The tides told them when to fish, when to travel, and when to gather shellfish from suddenly exposed beaches. Even today, tides remain essential. Harbors depend on tidal charts. Engineers use them to design bridges and coastal defenses. Surfers chase the perfect wave based on tidal shifts. And certain marine species like crabs, mussels, and sea turtles literally live their lives to the rhythm of the tide. Tides also help stir the ocean, moving nutrients, oxygen, and heat around the globe, keeping marine ecosystems healthy and dynamic. At their core, tides are the ocean's quiet response to gravity, motion, and time. They're a global phenomenon, but also a deeply local one, affecting every coastline in its own unique way.